In this video, we're going to learn about the principles of designing a database. First, we're going to design a database for our task manager project, and then we're going to go over to another project and analyze how it works. So let's get to it. For designing our database, I'm going to use a website called drawdb.app. And this is a free website, no registration required, and just click on editor and select the database you are working with. I'm going to work with MS SQL, and let's just hit confirm. And since we are going to create a task manager, let's just call it that. All right. Before starting to design our diagram, I'm going to tell you that throughout my career, the further that I go, the more I realize the importance of databases. Basically, most of the applications that you see, from the simple blog to ChatGPT, is just a bunch of data. And the way that we handle those data all depends on our choices on database and the way that we design our database. So it's the most important part of our application. And here you can see we have an add table button here. If I click on it, a table will be added here. We are going to call these entities. So this entity, I'm going to click on the edit and set a name for it. Let's call it user entity. And inside our database that we are going to design, we're going to have a user. Each user can be assigned to a different role. For example, one user can be admin, one user can be employee. Then each user can have been assigned to a department, and each user can have multiple tasks, and so on. So let's just jump in and start designing. Now we have our user entity. We need another entity called roles. All right. So as I said, each user is going to have a role, and let's just call this users. Let's add another entity called departments, put it here. Another entity for obviously our tasks. And that's all the entities that we need right now. Let's just finish this and we will add other entities bit by bit. Our role is going to have a field called title. And this title is going to be of type and varchar. Okay. Our title cannot be empty or cannot be nullable, and it's going to be limited to 255 characters. It's very important for us to limit our varchars because the limited varchars inside a SQL server is going to be handled very, very differently from the varchar max. It's going to be stored differently and it's going to be handled differently. It is very more optimized to use a limited varchar. And let me tell you, there is varchar and nvarchar. Varchar is non-Unicode, which is not supported of many languages, but nvarchar is Unicoded, and it's going to support multiple languages. Then here inside our user, this user can be an admin, can be employee, can be multiple things. So I'm going to add a field. Let's call it first name. It's going to be nvarchar again. Another field called last name, again nvarchar. Then it's going to have a username and it's going to have a password hash. So this is the fields that the user needs. Now, a department needs only one field called title, and let's give it an varchar. Now, that's for the department. And for our task, I'm going to add a field called title, another field for description, and for the limit, I'm going to put 600. Also, I want to add some fields for created at, and is going to be a date time, another field for expire at. So Here we can have a limited time for our task, and for created at, it's obvious that we want to know when it is created. I also want to create another field called state, and this state is going to be an integer, which is going to determine whether our task is done, it's unassigned, or it is on hold, or any other state that we have. Now for our data here, this state should be always filled, created at should be always filled, so these are not going to be nullable, but the expire at can be nullable because maybe the task doesn't have an expiration date. Then it should have a title. Our department also should have a title, and our user should have a username and password. So our task, we said it has an state. What we want this state to be is dependent on ourselves. I want to create another entity called lookups. This lookup going to have a few fields. One of them is entity, and it's going to be nvarchar. I always do this for my projects because in multiple entities, we are going to have something like state or something like difficulty, which has a limited options to select, and they are predefined. So we doesn't require to create a table for each of them for these predefined data. What we can do, we can create a lookup table, and in this lookup table, we can add our values based on our entity and attach this data together to create our system. The entity is not nullable. We do have a key, which is not nullable as well. This key can be integer, and we also have a value, which is going to be nvarchar. So this key can be called code as well, because when we want to search in this table, we want to filter them first by the entity. So let's say I have my tasks here. I'm going to say, bring me all the data from lookups, which the entity name is tasks. Then inside them, the ID might be different in multiple tables. So if we have this database on multiple systems, the ID could be different. But the key, or here you can call it code, the code is always going to be the same number. For example, 1, 2, 3. And I know which number is attached to what value that I want. So that's for my lookup table or lookup entity. Now it's time to wrap this up and attach our entities. So we said each user can have a department. To assign a department to a user, we need to add another field to the user. Let's call it department ID. And in here, let's give it integer. It's not going to be nullable because the user should have a department. Or if we want first to create the user, then attach the department to it, we can set this to nullable. But this is going to be a foreign key, which means that we have an entity and we want to attach that entity inside our users. So this user can have a foreign key to the department entity or department table. And when we set the foreign key, if, for example, we have department 1, 2, 3. When we define this as foreign key to the department table, if we put the department 4 inside this field, it's going to give us error because it says department 4 does not exist. So that's a good thing to have. Here, to attach this department to our department entity, I'm gonna, inside this dot, I'm gonna drag and drop it on the department ID. So here, as you can see, it attached it to the department. And our foreign key has a name right now. So as you can see, which is the name of the user table, then the field, then the table, the second table that we have, which is departments. All right. Now, the relationship between these two tables is one-to-many. So means that one department can have many users, but each user can have only one department. So that's the relationship between our users and departments. It goes the same for role. So let's add another field. Let's call it role ID. And here, let's put integer. This is not going to be nullable now because when we create a user, we must define a role for it. It cannot be empty. Again, select the role ID and drag it to the ID of our role entity. Now, these two are attached. All right. Now, before we attach the users to the tasks, let's first add this state to our lookup ID. Now, we know that this state is a lookup. It's coming from lookup. Okay, let's put this here and zoom out a bit. Okay, now let's go for our tasks. All right, now for our task, each user can have multiple tasks and each task can only be assigned to one user, right? But I want to categorize my tasks. I don't want just have tasks. We might have a task for opening the door, but we can't have that task near to task of developing a new feature. So what I want to do, I want to define another entity. I want to call it projects. So this projects entity is going to be categorizing our tasks. All right. Now for the project, just like other entities, it's going to have a title and varchar. It cannot be empty. And inside our tasks, I want to add another field called project ID. Why do we create the project ID inside task? Because each project can have multiple tasks, but each task can only be assigned to one project. So that's how it works. If I define the task ID inside my projects, each project can only have one task. We don't want that. Now let's attach it. All right. And now each project can have multiple tasks. Let's set this title to lowercase. It doesn't matter. It's just preference. I personally prefer uppercase, but lowercase is best practice because querying will be simpler. So here I'm showing you lowercase. All right, now let's put this down. Or let's not put this down, let's put this up. All right, now we can do something like this. We can attach a task directly to a user, which we should do anyway, but hear me out. Or we can attach a user to a project. So a user can have multiple projects, right? I can be in dishwashing project and I can be in development project as well. Then each project has multiple tasks, so I can have multiple tasks, right? I can be working on multiple tasks at once. So here are what I want to do. Because each user can have multiple projects and each project can have multiple users, that's called many-to-many relationships. We can't just attach the user to the project or vice versa. But what we can do, we can create another entity which is going to mediate between these two tables or these two entities. I will call it user projects. And what this entity is going to hold is two fields. One of them is going to be user ID, another one going to be project ID. Both are going to be integers and not nullable. And here I will attach the user ID to the user and project ID to the project. That's how it works. Let's put our department here so we have it nice and clean. So that's many-to-many. Each project can have multiple user projects. Each user can have multiple user projects. So in this way, we can attach these two together. Now for our tasks. If it's getting a little bit complex, I'm sorry, because I'm trying to explain the best that I can. So for our task, we're going to do the same thing. We're going to create another entity called user tasks. And these user tasks going to have two fields. One of them is going to be user ID. Another one is going to be task ID. Both going to be integers and not nullable. We attach them, user ID to users, task ID to tasks. So that's how it goes. Each user can be assigned to multiple projects, and each project have multiple tasks, and each user can be assigned to multiple tasks. Now, we want our user to only be able to be assigned to the tasks that are part of the project that the user is assigned to. And for that, we're going to go to the application side. So we are not going to handle it inside our database here. That's the part of the application side to verify the task that is going to be attached to the user. Hello again, everyone. So I'm Ali from Future, and when I was editing the video, I realized a little mistake I made here. So here we said that a user can have multiple tasks and a task can have multiple users. So for example, we are going to move the fridge. That's a stupid example. But two people at the same time going to move the fridge. So a task is going to be done by two people. That's why we are doing this many-to-many between users and tasks. That's totally depend on your business. It can be one-to-many. A user can have multiple tasks, but a task can be only assigned to one user. But since we are going with this approach, there is something else that I want to add to this user task. So let's add another field, call it state. And this state is going to be exactly like the state that we have on the task, but it's per user. So if we have two users doing the same task, what this state going to reply is one user has done the task and one user is in progress or had a problem and the task is in hold for that user. So that's that. And we can only set the state of the task done, completely done, when the state of all the users assigned to this task are done. So that's that. And we can have a relation between this and lookup as well. All right. I can't make the shape right. Okay, doesn't matter. So that's the little thing that I wanted to add to this diagram. Let's continue watch. And I think that's it for this diagram. We covered pretty much good things. Now let's go see another diagram that I created recently. So let's cover that as well. And I will save this diagram. Let's just save it right now so I don't forget. Here you can export as SQL, but since I want you to have exactly the same shape and the same places that these entities are, I will export it as JSON. All right, task manager, and I'm gonna call it Digidev. All right, I'm gonna put a mark somewhere. Let's hit export. Now we have it. This JSON file have the fields, have the what is it called? The coordinations, yeah, X or Y of the field of the table. So when you go to files and import from JSON, you will exactly get the same diagram that we created here. All right, now let's go to our other diagram. Here it is. Let's view it as light mode. So we get the same feeling from there. This is a quiz diagram, and it's for a project that I'm currently working on. Let's go here. As you can see, the colors that we have here, it's an area. It's just, you can add just an area, click edit, and set a name for it. The areas that you see here are schemas that I'm going to use in my database. When you export it to SQL, it doesn't export the schema for you. I just created these areas for myself to have a better understanding of which part I'm working on. So schema generally categorize our tables to parts. For example, here I have a GNR schema for my general entities. Then I have an auth schema for my authentication. Then I have a pay schema for my payments, and so on and so forth. So the project that is here is a quiz project, and the admin can go add courses, add subjects, add topics. Then it can create questions. Each question can have multiple answers. For example, one question can have 4 answers. One question can have 8 answers, as many as it likes. Then the user logs in, and the user create a quiz for itself. It can be from a template quiz, or it can be a custom quiz that it wants. So let's go to the tables, and I will explain to you in more details. Here is our GNR tables. We have courses, we have sources, we have topics, and here I put a note for myself. A course can be, for example, physics, mathematics. A topic can be algebra or thermodynamics. Then we have the question that is attached to topic, course, source. It can have a subject, and each question can have multiple answers. Then here we have our configuration tables, which is my lookup table, then my base settings, and frequent asked questions for the website. My user plan has just one more entity, which is claims, and each user can have a role. Each role can have multiple claims. So for each route in my website, I will assign which claims can access to that route. So that's for that. And we have a role claim that attaches these two. Each claim can be put inside many roles. So the user or the admin user can create the roles himself. Then I have my payments, which contain a plan. For example, a plan for 1 month and 20 quizzes. That's a sample plan. I have a discount table, which has a percentage, use limit, used count, created at, updated at. Some of these I put in all of my entities. And then we have a user plan. And from this user plan, I can create graphs, which user have bought which plans. I can have a user history, which user has bought the most plan, so I can give them additional discount. And all of them come from this table. Then we have, at last, our quiz itself. We have 2 types of quizzes. One of them is template quiz, which is, for example, for last year, the national quiz that has been taken place. We will create a mock quiz with the same questions, with the same order inside our template question and template. And user can just quiz this template again, just the same quiz that has been taken last year, for example. Then we have a quiz table, which is for users to create their own quizzes. Each quiz can have a pattern. For example, there are multiple websites for taking quizzes. We want to have a pattern for each website. So when user wants to create a quiz, it can select the pattern, and the pattern can have a pattern course. The pattern course is for example, I want mathematics to be first. 3 questions from mathematics at first, then at second, I want 4 questions from physics. To handle that, I have created a pattern course which assign the course, order them, and say how many questions should come from these courses. Then we have a base pattern which has a time for the quiz, and it has a title. It can be custom. Maybe a user wants a 90-minute quiz. Maybe a user wants a 10-minute quiz. Then we have the quiz itself. When the user creates a quiz, a random number of questions will go inside quiz question and the quiz starts. Then we have a state which is attached to lookups, just like the task manager that we created. And that's the base of every databases. So I believe you can create your own databases now. So I highly suggest you select a topic, for example, hospital management, school management, something that you are familiar with, and try to understand the way it works and create a diagram for yourself. Then at the end, let's go here. At the end, go to export SQL, get the SQL, and create your database. So then you can have your database visually in your database. All right. Thank you for watching. Hope this was helpful, and I will answer any question. Just comment them. If you click that like button, it will help me so much. Thank you. Bye bye.